Alright, so 7.1 notes. We're going to find the value of x in each diagram. So looking at this triangle, we can tell it's an equilateral triangle because all three sides are equal. So that means every angle is going to be 60. 180 divided by 3. So if the interior angle here is 60, we have a straight line, this angle is going to be supplementary to it. So that's 180 minus 60, which means x is 120 degrees. And moving on. We have our marker saying we have parallel lines. And since we have parallel lines and we have transversals, you continue the lines. And there's a lot of different ways to prove this. But since we have 70 degrees here, we actually have alternate interior angles here. We also know that here and 70 is going to be supplementary angles, which means this is going to be 110, which makes this 70. Two ways to go about this. The longer way is to add these up, subtract from 180 and find out this angle here, and then subtract that from 180 again to find the supplementary angle here. But if you remember from the previous unit, these are called remote interior angles. Remote because they're kind of far away, and they are on the interior. Those two angles add up to the exterior angle. So if we add those up, we get 119 degrees. All right, write the equation of perpendicular bisector of the segment with endpoints P and Q. First thing we need to find is our slope. And remember, this is very important. It's y minus y over x minus x. Yum yums on the picnic table. Don't do it upside down. Also, you can see we've got some negatives here, so you got to pay attention to that. So we have negative 2. I'm going to start with this one and go this way. Minus a negative 2, which is going to become plus. Since I started with this number, I have to start with negative 3 on the bottom. I cannot go round robin. So on the top, I'm going to get 0. And on the bottom, I'm going to get negative 8. Not that it matters very much. Because 0 divided by any number is 0. That means we're going to have a horizontal line. Now, this is the one time that the perpendicular is not going to be opposite reciprocal because there is no opposite of 0. There's really no reciprocal here. So you just got to remember that we're talking about a perpendicular line for this one. All right. Now, so we know the slope of the line, and we also have to find out the midpoint because it is a bisector. So that's where we're going to add x and x. So negative 3 plus 5 divided by 2, and negative, whoops, try again, negative 2 plus negative 2 divided by 2. That's going to give me a midpoint of 5 minus 3 is 2, divided by 2 is 1, and negative 2 plus negative 2 is negative 4, divided by 2 is negative 2. So I know it's going through the midpoint of 1, negative 2, and it's a vertical line. Now this is a special problem because remember, vertical lines just have an equation of x equals. Therefore, it is just going to be going through whatever the x coordinate is here, and x equals 1 is the perpendicular bisector of those 2 points. Now over here, I do the same thing again. M equals 0 minus negative 2, which can become a plus, and 5 minus 5. These are both special lines. This is going to lead us to 2 over 0. That is a vertical line, which means the perpendicular bisector is going to be a horizontal line, which is going to have an equation of y equals a number. So now we need to find that midpoint to know where it's going through. So 5 plus 5 divided by 2, and 0 plus negative 2 divided by 2. That's going to give me 10 divided by 2 is 5, and negative 2 divided by 2 is negative 1. So this bisector is going to be going through at y equals negative 1. Okay, so we have a theorem here, new one, pretty simple one. It's basically to find out the interior angles, what they add up to in any polygon. Very simple formula. N minus 2 times 180. So the number of sides minus 2 times 180. So in this case, 6 sides, that's my n, minus 2 is 4, and 4 times 180 is 720. So this shape right here has 720 degrees locked inside of it. And being that it is 6-sided, it is a hexagon. And it included a little chart here for you to remind you the names of the most common ones we'll be dealing with, up to and including what's called the n-gon, which means you just fill in the number of sides. So we don't worry about the special name for a 50-sided figure, we just call it 50-gon. Okay, example 1. Find the sum of the measures of the interior angles. Don't even have to name it, but we will. So we just count them off. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is an octagon. Right? Octopus has 8 tentacles. So we're just going to fill that into the very simple formula. 8 minus 2 times 180. So that's going to be 6 times 180, which is 1,080 degrees. So this shape has 1,080 degrees trapped inside of it. Example 2. Sum of the measures of the interior angles of a convex polygon is 900. Well, now we're going to work backwards. So let's go back and get our formula. N minus 2 equals, N minus 2 times 180 equals 900. We do know this, so we're just working backwards. So we're trying to get to this n right here. How do we do that? We need to get rid of that 180 first. Okay, so we just do 900 divided by 180, and that's going to be 5. So n minus 2 equals 5. Add 2 to both sides. That means our shape has 7 sides. And if we go back to that previous chart, it is called a heptagon. Okay. Now, the nice thing about this is you can plug this number back in real quick with your calculator and do 7 minus 2, which is 5, times 180, and you'll get 900. Where you can check your answer. Very convenient. Okay, now we're coming to a corollary. A corollary is kind of a subset or an addendum to something we've already proven. All right? The corollary to the interior angles theorem is, yeah, we know that n minus 2 times 180 will give us the total amount. This is just, since we're going to deal with a lot of quadrilaterals, just know it's 360. That's it. And if you don't remember that, just go back to what you know. You know the square, which is a quadrilateral, has 4 90-degree angles. And 4 times 90 is 360. And that can be your, benchmark to always remember that rule. Okay, so we have 4 angles here. If we just add those up, 108 plus 121 plus 59. That's 288 degrees. Okay, so I used my example before with triangles. You have 180 hours to spend, and you have 3 stores to spend it. Well, here, you have more money. You have $360. You spent 108 at this store, 121 here, and 59 here. That means you spent $288. How much left do you have in your wallet? 360 minus 288, which means x is 72 degrees. You have 72 hours left to spend there. Okay, example 4. Home plate for baseball field to show. Is it regular? Well, step back to previous unit. A regular polygon means that we have the same angles. I can spell. And when I say same, I mean congruent. Congruent angles and congruent sides. Okay? So congruent angles and congruent sides. Well, we don't know anything about the sides on this one. It's not marked. We can't assume. But look what we have here. We have 90, 90, 90. And these two right here are marked with single arc marks, which means they are not 90. We don't know the exact degree measurement, but they're not 90. So the answer is no, because the angles are not congruent. Now, what are the measures of C and E? Well, let's think about it. We have 1, 2, 3 90-degree angles. That's 270 degrees. Now, we have a 1, 2, 3, 4, 5, a pentagon. So 5 minus 2 times 180. So that's 3 times 180, which is 540. There's 540 degrees in a pentagon. We use 270 at the 3 right angles. So what does that leave? That leaves 270 degrees. Now, since these both have one arc mark, that means they're equal. So we need to take 270 and divide by 2, and we're going to get 135 degrees each. Just go step by step. New theorem. The sum of the measures of the exterior angles of a convex polygon, one angle each vertex, is 360 degrees. So one way to remember that is you're going around the outside of the shape, and round means circle. So there's 360 degrees in a circle. You spin yourself around 360 degrees. It's one complete turn. So you remember that no matter what the shape is, this happens to be a pentagon with 5 shapes. Those 5 angles are going to add 360 degrees. So let's go off of that. Right here we have 4 angles. Okay, 4-sided shape. We know that 2x plus x plus 89 plus 67 must add 360. Because we're going around the outside of the shape. So I'm going to join like terms. 3x. 89 plus 67 is 156 equals 360. I'm going to subtract 156. I'm going to get 204. And that's going to be divided by 3. Oopsie, wrong number on the calculator. 204 divided by 3 is 68. So x equals 68. And that's all we had to do. If it wanted to find all the angles, this would be 68. And 68 times 2, just out of curiosity, is 136 degrees. And that would be your angles. But again, the nice thing about this is you can add those 4 numbers up now. They better add up to 360. All right, here we have a trampoline. The trampoline is shaped like a dodecagon. If you look back at the chart, that means a 12-sided shape. If it's a regular shape, that means every angle on it, this angle, that angle, these are all equal. And all the sides are equal also. So the measure of each interior angle, we're going to use our formula. 12 minus 2 equals, sorry, do it again. Should be in a hurry to get to the other side. 12 minus 2 times 180 equals the total number of degrees. So that's going to be 10 times 180. That's 1,800 degrees inside that dodecagon. Well, we want to know each angle, so we're going to divide by the 12 sides. So 1,800 divided by 12 is 150 degrees at each angle. Now, find the measure of each exterior angle now. So exterior angle, remember, it's going to be 360 degrees divided by the number of angles. 360 divided by 12 is 30. So that's 30 at each exterior angle. And that's it for the first lesson.